Hi everyone. So you can see that there are some signs in front of you. So today we are going to classify the sign language. Okay, the different notations in the sign language. So for that, I was going through a technical paper here. So you can see that there is a American Sign Language and there is English, Indian Sign Language. So you can see that there are different notations for the alphabets within the sign language. You can see that there is A, B, C, D associated with a particular sign, hand sign. So we are going to use a similar data set to classify the images for different alphabets. We will classify A, B, C, D like that. So we'll get into that. Before that, I was just smurfing or surfing to the Google, and I found a data set on the Kaggle. You can go to the Kaggle and register or sign in, and you can download this dataset. I will put the link in the description. I can also share the dataset itself. It's just a 34 MB. You can download it. Okay, I have pre-downloaded it here. So we need to look into the dataset. So there is a x and y dot numpy files. So these are the numpy files. So we need to convert the numpy array into a image. So let's do that first. Let's see what is the data inside that. So we need to create a Python script. Let's see. Let me save the script as convert numpy to the file. Okay. So first we need to import the numpy. Okay. Then we might need OpenCV to save the images. So let's import the OpenCV as well. You need to download the OpenCV if you don't have it. You can just do pip install OpenCV-Python. Okay. Same for the NumPy. If you don't have the NumPy, you can install it by using pip install NumPy. So let's read the dataset. So we need to look at the x.numpy. Y.numpy is currently no use for us because this is just a classifier. Okay. So we are not going to build something based on the YOLO or something based on the Keras uh, models. We will use that in the backend, the Keras one or the TensorFlow one. So I will show you how to do that. Don't worry about that right now. So let's import our dataset. Let's say dataset is equal to np dot. Let's see what's the x dot numpy. So we need to give it the path here, x dot npy. Because the file is in the same directory, we can directly give the x dot numpy. Otherwise, you need to give entire path here. So let's see what's inside that data set. So let's print it out. Let's see what's the shape of the data set so that we can understand what's inside it. Let's see what's the shape of the data set. So type in command prompt if you are on the Windows or terminal if you are on the Linux, and just do Python. What was the name? Convert numpy to images. Can't open. No such file. Okay. What I can do is I can select it all. CLS Python. Okay. So dataset has shape 2062 by 64 by 64. So what you can see with this shape is there are 2062 images with width and height 64 by 64. So definitely these are the grayscale images, black and white. So let's see how the array looks like. Let's print it out. Data set 0. Okay, let's see how it performs. So you can see that the single image contains some float numbers, float 32 I guess, with zero point 0.4 or 0.47 like that. So we need to multiply this. So these are the converted numbers. So we need to rescale them again. So first thing we need to do is let's see if we can reshape this. Yes, 64 comma 64. Okay, so we need to reshape them. I hope this is reshaped. Okay, and we also need to, like, let's say multiply it by 255 because I guess these are the normalized numbers. So let's multiply it. Let me show you the result first so that you can understand it why we need to multiply by 255. So let me save this image into a OpenCV format. Okay, so cv2.imwrite image name, let's say irst.cpg, comma, I need to copy this entire thing here. Okay, let's see if we can save that. Okay, so that's saved, so it has to be here. Let me open it. You can see that it is a blank image, all black pixels. That's why we need to, like, rescale them. So let's multiply it by 255, and now we might see a better image. So you can see, let's see. So yes, you can see that there is hand and there is some gesture. So let's do it for all the images. Let's create a folder named images, and we will save all the images here. For we will do this. Okay, for the data in DSP, for data in dataset, we can directly save the image. Let's do we need to assign a counter. So let's idx comma. It's always better to use enumerate. What it does, it gives you a counter for each iteration. So we can directly give here the id str idx plus. Okay, so this is our image. We are going to do idx. We need to reshape it, rescale it, and denormalize it and save it. Okay. So I hope this will be faster because the shape is 64 by 64. So I don't think that will take a lot of time. Let's try this out. We'll see if there are any errors. Uh, Final check before it. Okay. So we also need to like add images folder. Okay. So this is images folder. So we need to save them inside the images. Okay. I think it's fine. And this one as well. Data. Actually, we can also do that like this. If we are going to use the data, we don't have to like give that index because data itself is an umpire. If we are going to use the data set, we need to use that index. Okay, so let's verify it once again and let's try it. Okay, it will take time. Okay, now it's finished. Let's see in the images folder. We can see that we have all the images. I think there are 2062 because it started from 0.jpg. There is a 2062, 2061. I hope. Yes, the last images. So let's have some images. Let's see. These 50 images looks similar. Okay. We will have these images as a testing images, these other images, and okay. So let's create a data set with this 50 images. Okay. Control C. I'm going to copy them into. Uh, let's see what is the sign for that. Is there any specific sign for that? Okay. I hope this one is the thing, but I'm unsure about it. Let's see. Is there anything similar? Well, this looks like O, but from the front side. There are three fingers. Okay. So in the Indian Sign Language, the three fingers are like this. Let's copy something which is similar to this. Okay. So I think this one looks similar. This is O in the American Sign Language, definitely. And this one I think I know. This one is this. Uh, what's that? The sign language is complicated, man. It's taking a lot of time. I think that's K, but I'm unsure. Maybe let's choose one another. Yeah, this is I think W. Okay, so we will select O and W. You can dig into the sign language and select the images according to yourself. So 2004 to 2054, let's choose it. Okay. I mean 204 to 254. Let me copy it as O. Let me rename this folder as well. And paste. Okay. So let's choose the W as well. Where is it? This one. Yeah, it starts from this image to 615 to let's say 665. One selected. It doesn't matter if you select 50 or 51. Just copy them and paste it for W. I hope that's W. Yes. So let me paste here. Let's see. Okay. Okay. And in the O as well, we have 51 elements. So now we will move on for training. Okay. So you need to go to this website, teachablemachines.withgoogle.com. So this is the simplest way to train a classifier. Okay. Get started. There are different projects you can choose from: audio project, pose estimation project, the image project. So we are going to use the image project. Okay. So standard image model, there are different types of it. We will choose the standard image model and we will upload our images. So let me upload the class 1 images here. This is the images for O. I just need to drag and drop them. Okay, I need to drag and drop that. Okay, so it will load all the samples. Okay. Similar way, we need to upload the images for classes as well. Let me upload the images for W as well. So, okay, so all the images are now uploaded. So we need to edit the class as well. So let's name this O and let's name this W. Okay, so once this is done, you need to start training. This is just a GUI-based training. We'll get into the inference code later on. I will explain it in the detail. You need to start the training by clicking here. It will prepare the data and do all the pre-processing, then do all the post-processing to show you the outputs. So you need to stay on the same page until the training is completed. So don't change your tab or close your browser. It will take few seconds to complete the training. Once it's done, we can use the H5 model or we can use the TensorFlow Lite model. We can use it in the web browser or we can use it in the mobile application. Now the training is done. We need to test it. Okay. Let me just upload few images. for testing. So sign language. So we have all the things in the images. So let me see 254 and after that. So we have image until 254 for training. So let's test it with other images. Okay, let's test it with 256 image, which is the unsent data. Okay, so I have tested it here. So you can see that here that it's O. It's telling that it is 100% sure that it's O. Okay. Similar way, you can also test it for W as well. For W, we have selected around 665. Okay, so let's choose any other 666 image. So it says that it's W. That's 100% sure. So it is a very lightweight model. So you can export it by clicking here, export the model. You can export it in the TensorFlow model, Keras model, the TensorFlow Lite model, or you can export it with the JavaScript, e5.js, or anything, so that you can use that in the web browser. So you can also download the model with JavaScript if you want to use the TensorFlow model or Python. You can download it as well. Okay, so you can use the saved model. You can use the weights. You can download the model by clicking the download button, and you can run that on your local machine as well, or any Django application or anywhere else. The next thing, the inference code is this. You need to copy this inference code and paste it in the Sublime text and use that for detections. You just need to give the image path here. Okay, so this will be like uh, something dot jpg or anything. The image path. The size can be here 94 by 94 or 224 by 224. I guess the algorithm at the backend is converting the image into 224 by 224 size. So everything will be the same. Just change these things. Change this thing. Okay. So you can download the Keras model. You can download the TensorFlow Lite model so that you can use that in the mobile applications. Okay. For Android or Coral, anything. Okay. You can also download the quantized version, the floating point version, HTTP version. There is a lot of options. So we'll get into the specifications later on in the upcoming projects, but right now we don't have to go deep into that. So if you download, let me just show you what's the size of the model. So it will be very light model. It's converting the model to Keras first, and then it will download. Let's see what's the size. It will be less than 2 MB or 2 to 3 MB. Once you convert it to a TensorFlow Lite model, it will be compressed, more compressed, and it will be less in size. Okay. So TensorFlow Lite, you can do different things. When we get deeper into that, I will explain how we can convert TensorFlow model for the less size, or how we can convert the TensorFlow Lite to the TensorFlow Lite model for better accuracy. So this is downloaded. Let me see what's the size of that. Control X, sign language. Let me paste it. So this is 2.33 MB. So once I once I download, once I convert it into a TensorFlow Lite, the size will get reduced. Okay. So let's see. By the time it's happening, let's just unzip the file. so that you can see the, the model here. So this is the Keras model, and these are the labels.txt. Label.txt contains this 0 and this O and W with index 0 and 1. Okay. So these are our classes. We can say the labels. It's still converting it into a TensorFlow Lite. It can take few minutes. We'll see that. And yeah, now it's getting downloaded. That is a Lite version. So let's Control X, Control V. So the size is 1.99 MB. We can see that here. Mm, Let me add it to another folder here. Like it, yeah. Okay, that's added now. Let me put it into a TensorFlow folder so that the models don't get like mismatched. Let's start here. So you can see that this file was less in size, but once you decompress it, it becomes little bit bigger. Okay, so we have a 2 MB size for our model and 1 KB size for the levels. You can see the levels are the same. Okay, you can use this TensorFlow Lite model. You can use the script here in your mobile application. For the Keras model, you can use the same script and just change the image path. Also check on the TensorFlow version which we are using. I think this supports the TensorFlow version 1.14.1. Okay then, bye. I hope this is good. You can also train different pose estimation models or sound models as well. In the next project, we will go deep inside it, how the batch processing is done, what are the batch inputs, what are the different kernel sizes, what are the convolutional layers, what are different models, sequential models, what are the activation functions like ReLU and softmax, and what are the different errors, mean squared errors, and how we can compile a model, how we can fit it, how we can do a lot of things. So we will get into that. We will train a purely Keras model. So stay tuned. I hope this is good enough for today. Bye.